Okay, optical fiber fusion splicing. This is what we're going to do today. Now, before we go any further, I'm going to ask you to stop this right now, watch the safety video that is going to be included in the description, and then after you watch that, come back and continue watching the rest of this video here. So please watch the safety video first now. Okay, now that you have watched this video, we're going to take care of a couple of basics here. Now, there are a couple of basic splices when it comes to optical fiber. One would be fusion splicing, and the other would be mechanical. So fusion or mechanical splicing. Today we're going to take care of the fusion splicing. All right. Fusion splicing is joining two fibers together, two optical fibers together, bringing them close to each other, and then applying a spark right across where that interface is, where the joint is, in order to basically fuse them together with the help of a heat. It's just almost like welding glass, but not really. But that's the closest thing that can come to as far as analogy. All right. Now let's just take a look at the basic construction of the fiber that we're going to work with. Fiber consists of a core. All right. So here's the optical fiber. This will be the core. Let's just maybe here, that's going to be a little bit better. Then around that core there is going to be something that's called a cladding. Cladding. C-L-A-D-D-I-N-G. Right? Now, the core in this single modes, okay, there's single mode and multi-mode fibers. Today we're going to splice single mode fiber. So the single mode fiber, the diameter of the core would be something around 6 micrometers. All right, so that would be something like that. Then, well, basically most of it about 6 micrometers, and then the size of the cladding, the diameter of the cladding here, this would be something like 100, oh, well, something like, it's actually 125 micrometers. All right, 1 micrometer is 1/1,000,000th of a meter. So here's the core, here's the cladding, and then everything is coated. All right. With a coating. All right. And the diameter of that typical is 250 micrometers. So that's we're dealing with things that are quite thin, basically thinner than human hair. Now, the idea of fusion splicing is bringing those fibers together, applying a spark at the interface or at the place of joint, and then due to the heat that is being applied between at that point, those two pieces of glass are being, or the fiber, the optical fiber, are going to be spliced or fusion spliced. Mechanical splice we're going to take care during the next lab, and mechanical splice is a little bit different. There's no fusion going on. It's bringing the optical fiber into something that's called a ferrule of a connector, and then it's going to be aligned, the fiber is going to be aligned pretty close with the ferrule of the connector, and then there's going to be a little tiny bit of an index, something that's called an index matching gel, that is going to help the light pass through a little bit easier and more properly. Okay, so that's as far as fusion splicing and mechanical splicing. Where do we use and which? All right, well, fusion splicing, most of the time you're going to see when you do the long distance sort of runs. I'm pretty sure quite often you're going to see something like utility pole, where there's sometimes you're going to have hydro going in there, going through that, so there will be hydro wires, or maybe there won't be any, but you're going to see something like well, here's the ground, all right. You're going to see something along a little bit lower. There's going to be the kind of mysterious looking wire there, kind of black thick wire. For the most part, that would be the data or the data line, and for the most part that would be the optical fiber, loose tube optical fiber cabling, very tough, thick, resistant to elements, resistant to physical abuse, because it has to withstand all kinds of things. It has to be there, you know, day, night, winter, summer, whatnot. Okay, and you're going to see something like a barrel-looking object, something like that, over here, and you're going to see a little bit of lines going there, some cabling going that. So you're going to see something like that. It's like a barrel-looking object. This is something that's called a FOSC, A-F-O. FOSC, okay, so that stands for Fiber Optic Splice Closure. Okay, what's happening in the FOSC is that there will be optical fiber going forever. It could be 2 kilometers, 5 kilometers, or whatnot, going that way, and there will be other optical fibers going, the cabling going 5 kilometers, maybe 10 kilometers that way, and they're going to meet here, and they're going to have to be spliced somehow. So that's where you're going to see, for most of the time, you're going to see the fusion splicing taking place. All right. Now, what does the FOSC look like inside? It looks like this. I just happened to drive by and take one off. No, just kidding. Before we do that, because sometimes you're going to see a van pulling in right beside somewhere here. There will be our company truck, okay, pulling somewhere there, and you're going to see that long, thick, black cable pulled right inside the van, and the door will be closed. So you're going to see something like that, and most of the time you're going to see a ladder, you know, the big ladder here, so so the technicians could you know, get at it and take it off and bring it into the van. The reason why this thing is being brought into the van, so the environment is nice, dry, and clean when fiber is being spliced. Fiber does not like dirt. Fiber does not like dust. Just think about it. This is about 6 micrometers inside, and the light has to pass through it. The dust is very comparable to that side. The dust speckles, they will be very similar to the size of that. So if there is some sort of a dust that lands on top of that interface here, or the end of the core, then it could actually blind the fiber, and through optical fiber there's light going through, so it could actually be blinded. All right. We're going to see some of those fibers under a microscope today. Right? Now, this is what the FOSC looks like. It's a little bulky here, but that's the way it looks like. Okay, this is one of the older ones that's being decommissioned, and it was just donated to us so we could play with it. Well, not much we can do with it except just open it and see what's inside. So let's take a look what's inside this thing here. Hopefully I'm going to be able to do that without causing too much mess here. All right, so here's the ring. Okay, and then we're going to pull this cover off. Just bear with me here as I take this cover off here and put it on the floor. Alright, so what do we see inside here is basically there are, well, from the outside, this is the older version of that, so the technology has gone a little bit better now. So the interfacing or the insertion of the the optical fiber cables is slightly different. Okay, so now, but the idea is the same. Put those fiber optics in a way that these are sealed, nicely sealed. Okay. Now inside, what you're going to see is a bunch of trays. Right. Once those things are in, those cables are in, you can have trays in here, and they could be locked into place, into position. See if I can do that. Here, there. So you can have that one of those trays up, and you can work on this tray. What's inside those trays? Let me just close that now. Is basically there are optical fiber strands here. Now see if I can put it under the other view. And that's what they look like here. Just gonna push this thing aside here and zoom out a little bit. And maybe we should zoom in and focus. Alright, what we have here is the fiber optic strands. Right here you can see that. I'm just going to pull that thing off. And here you're going to see those optical fiber strands going in one way, going the other way, and they would be kind of wrapped around the tray here. So you can see those optical fiber strands. And the splicing happens right here. That's where the splice is. And those optical fibers, I'm trying to stay in focus here, they will be put in something that is called the protection sleeves. Because once you strip the fiber off the coating, there's nothing to protect that. This is a piece of glass or very thin plastic. It has to be protected physically somehow. And once those splices are done, the protective sleeves are being inserted in those holders right in the tray. And that's how they stay in there. Okay, so this is pretty much what's happening inside those FOSCs, right? A very popular activity these days. Now this is an old one, as I said. There will be right now the technology is a little bit different. The cables, the optical fiber cables, are being inserted in that in a much easier way than they used to be. There used to be involved like a lot of stripping there, and those fibers have to be sealed properly and heated up and all that stuff. Now things are more technician friendly or installer friendly. Okay? If you want to investigate this further, there's a bunch of YouTube videos by a bunch of technicians pulling those, showing what they do while they do the FOSC splicing or FOSC work on the FOSCs. All right, now let me just make a little bit more room on our board here. As I said, we are taking care of the fusion splicing of a single mode optical fiber, and the differences between single and multi-mode optical fibers we're going to take care of during the theory lesson. This is a lab demo that we're going to do, so I'm going to try to keep it as short as possible, and from our experience that is sometimes it's more possible than others. Okay, now what's involved in fusion splicing of an optical fiber? There is one, there's some stages. First, we need to prep the fiber. And in order to prep the fiber properly, see, I still have some residue of some of the sealant that was used in the old FOSC here. All right. Okay. So first thing, what we need to do is I'm going to show you. This marker doesn't want to write anymore. Let's try this one here. Well, there's a fiber, and the fiber is broken, or there's an end of it somewhere, and usually when it happens, the end of the fiber is not properly prepared. It has to be properly prepared. What do I mean by that? When you have a string that's made of glass, it's going to be flexible, right? Because it's very thin. It's just like human hair, but it's glass. Or right now they're using plastics as well. When you break that, what happens to glass when you break it? Glass shatters. It's glass, okay? So it shatters. So what this thing is going to look like? Let's see. This is the cladding. Here is the core, and it's surrounded by cladding. Okay. Now, of course, because that thing is broken, so it's going to be basically, it's going to look like that because it's a shattered glass, right? Well, it's the extreme of that. And let's say there's going to be another one of that right across. Here's the cladding, here's the core, all right? Now, those things are unspliceable. These two ends are not spliceable because those ends are not straight. In order to properly prepare the cable, we need to do something that's called cleaving. All right. So let's just take care of the cleaving. All right, cleaving the fiber. All right. Now, what happens? We need to bring those into a state. These two fibers. That there's one fiber here. Okay, so here's the core. Here's the cladding. Now they need to. If you look at them from the side, it needs to be nice and straight. Okay. And then the other one, the other fiber that needs to be spliced there, it also needs to be nice and straight. We need to accomplish a straight edge, a straight, nice 90-degree edge on each end in order for those things to be spliceable. Now, when they're at this state, they are going to, we can bring them together, align them properly, and then apply the spark. What happens in the fusion, during the fusion process, is that when these two pieces of fiber are being brought very close together, there is going to be an electrode here and another electrode here. Well, they're going to be the same size, a different size. Once those fibers are being brought closer together, then those electrodes can produce a spark. How are those things being aligned? Well, the fusion splicer is going to introduce a little bit of a light under an angle on one side, and it's going to measure the light under an angle on the other side. What that is going to happen is also there's going to have there will be two cameras internally built in the fusion splicer. That one camera is going to look from one side, let's say this here, and the other camera is going to look at a 90-degree angle, so those fibers can be aligned properly in 3D. Okay, and then once they're aligned, then the spark is going to happen, and it's going to fuse those two pieces of fiber, and they're going to look pretty much like one continuous piece of fiber. And after that, when this thing is done, the light is going to be injected from an angle and is going to be measured from an angle just to measure the signal loss at the splice. So the fusion splicer aligns those fibers, provides a spark for the fusion to happen, and then it basically tests the job, if the job done was good or not. Sometimes the splice needs to be redone if the signal loss at the splice is too great, usually from 0.01 to 0.0, well, sometimes 0.04 dB or decibels, signal loss is acceptable, but we're looking at anything between 0 to 0.01 of a dB loss. Now, decibels loss, remember when we talk about power, if you lower the signal 3 decibels, you are reducing the power by half. Also, it goes the other way. If you are making the signal stronger by increasing the strength of the signal by 3 decibels, then you're doubling the signal. So a dB scale, it's a reference measuring scale. Right, so anywhere from 0.00 to 0.04 decibels is still acceptable within the industry. However, different companies will have different standards, and as time goes along, things might change. Right? Okay, so first thing what we're going to do is we're going to do the cleaving. What does the word cleaving come from? You know, from the meat cleaver. Remember, the butcher would have the big knife, cleaving, chopping the meat. Cleaving, so we're cleaving the fiber, it's a chopping, cutting the fiber. There are different types of cleavers available on the market. They work in a slightly different way. Basically, what is involved is the fiber is being laid on some sort of surface and is being just touched with a sharp diamond edge. Okay, and then once this is called scoring. So once the fiber is touched, so here, for example, let's say this is the optical fiber. It's being laid on the surface. It's being touched, just touched with the diamond blade, and that produces enough of a score. So when you bend that enough, it's going to break nice and clean right at that spot where it was scored. There are other types of cleavers that, well, right now, most of the time you're going to see the tension type of cleavers. So the fiber, the optical fiber, is being inserted in and being held from 2 sides, and then we're going to the cleaver is going to apply outward tension. So it's going to pull on that the fiber strand a little bit, and then the diamond is going to be lowered and just is going to score that, just barely touch, just enough. And once there's the tension and the diamond blade touches that glass surface, then it just basically it separates, and with having nice clean edge. Yeah. All right, so we have a Corning cleaver here. This is part of the mechanical splice kit, but for the purpose of this exercise, we can actually use this cleaver to cleave our fiber. I'm going to show you how it works, the insides of it. Just prepare the space here a little bit. So this is basically what it looks like. Not much from the outside. Well, it can cleave multiple types of fibers. So first we need to prepare this thing as inserting the proper dies or rails into it. All right. So first what we're going to do is we're going to take a look at what's inside. And this is how we open this one. So you just press on that lever here, and you can open the flap and see what's inside this thing. We're going to take this rail out because we're not going to use this. We're going to use another type of rail. Let's take a quick look at what's happening at this particular cleaver. Focus, focus, focus. All right, so we do have a diamond blade. Where it is in this particular thing, it's, you see that little, like a little line here? That's the diamond blade, right? How is it that the optical fiber is being cut? Is being inserted right here. This is not a fiber, this is like a zip tie here, but you know, we can actually see that. You won't be able to see the fiber that much. So that thing is inserted here, and once this, if this, well, it's inserting it like that, when this thing is closed, all right? And here is the cleaving button. All right, see what happens when I press this button? It is going to push whatever is between this surface, and that surface, it's going to push that right onto the blade, right? And then the blade is going to cut that. Now there are two other buttons here, the red button and the black button. So now when we close that, when you push that button, it's going to operate this little lever right here, and this is spring loaded. Sorry, I'm pushing that thing by accident. Right here. Okay, so basically it's spring loaded, and it basically holds the fiber against this surface here and that surface over there, and that's how the fiber is being held. So there are some actions that need to be applied in there in certain order. So first, what we're going to do, we're going to use there's one, and there is a rail right here. We're going to use two inserts specific for this type of fiber that we're actually using. So here is that there's the main rail that is we're going to insert into our cleaver. So that fits just like that. Okay. And then we're going to close the structure. Just trying to have this thing in focus as much as possible here. All right, and we're going to close that structure right here. So now we're ready to. This thing is ready to be used with the fiber that we have. What we have is a single mode fiber strand. It looks like this. Let me just grab that here. This is a single strand of a fiber, optical fiber. First we're going to strip this thing off the coating, and then we're going to strip it off the coating first, and then we're going to clean it up a little bit with isopropyl alcohol, put it in the cleaver, cleave it, and we're going to use this fusion splicer that we have to perform the fusion splice. Okay. All right. So first thing we're going to do is we're going to get the insert, and the insert looks like this. It's part of the kit. All right, and the kit. Okay, so it has two sides. It's for the fan out kit, and for the 250 microns fiber strand. Oh, good, because this is a 250 microns strand. Under a microscope, this looks like this. Let's see here. There we go. All right, I'm just going to, just as a reference here, that white line that's there on top, that is a stapler, the stapler that you use to staple pages. So that's basically what this single strand of a single mode or a multi-mode, because it's 250 microns, you can't tell unless you look inside what the core is, or if you look at the specifications of that. Okay. All right. So now, first thing we're going to do is we're going to strip the fiber, the optical fiber, from our of the coating. Now I have a lot of buttons here to press, so bear with me because I'm going to try to give you as much of the procedure as possible without missing any steps, so you can see it as properly as you possibly can. Well, what we're going to do is we're going to fusion splice two pieces of fiber together. I think you can see it. Now, because one fiber line goes forever that way, the other one that's going to be fusion spliced goes forever that way, so we have to remember first to put the protection sleeve first, because after we fusion splice it, we won't be able to put in the protection sleeve. Right? So first thing first, we're going to thread the protection sleeve onto the fiber, and it's just like threading a needle. Okay. I'm trying to, there you go. Okay. we just have threatened we threaded this we have threaded this fiber onto the protection sleeve. Now, because we just have two short pieces of that, I'm going to remove it on the other end, but we're going to pretend that this thing is being put on. Alright, so this thing goes aside, and we're going to do the stripping of the optical fiber. Now, what we do have here is a optical fiber stripper, and it has grooves in it, just like the electrical wire stripper, but this thing is made for fiber. What does it have? It has a 125 microns groove, it has 250 microns groove, and it has a 900 microns groove, which are these three grooves here. Obviously, the 125 microns is going to be the smallest groove right here. So you can almost can't see it, okay? But trust me, it's a precisely calibrated stripper that has the groove that is going to strip the 250 microns coating off of the fiber that is inside, and it's going to strip it right to the cladding, okay? Because it has 125 microns, and the cladding is 125 microns. Cladding stays. We never strip it to the core because we would just not able to be. We wouldn't be able to work with that. So we strip it to the cladding, so we can fusion splice the core and the cladding together. Okay? So here's the procedure. First thing what we're going to do is we're going to insert that, and I'm going to do it twice because we have a left side and right side. So let's see how much of this thing you can catch when we do the process. So first thing we're going to do is we're going to open the insert here, and here is the groove that the fiber is going to go in. Now, for different type of connectors, you're going to have to measure things, how much to strip and how much to leave things stripped and cleaved and whatnot. For the purpose of this exercise with this fusion splicer that we have, we're going to do it this way here. The purpose of this is to insert that, and so this thing is being held, so we can actually insert that into the cleaver properly. Okay, that's part of the process. So how much should we have left? How much of the fiber should we have left passing the nozzle of this holder? Okay. Well, it's going to go inside the cleaver here, and this is where the cleave is going to happen. Something about here. Remember that when we open that and take a look inside. So once we cleave it, we're going to end up with two pieces, and we're going to have to remove the scrap piece out of here and remove the good piece out of that side. All right. So what we need to do is we need to make sure that we have enough on this side passing through, so we can comfortably grab it and dispose of. Because these are sharp objects, they should be treated as sharp objects, and you cannot just throw them in the garbage. You have to dispose of them properly. Okay, okay, so this is basically that's a good comfortable length for us to grab that thing later when this thing is cut. So we're just gonna have to make sure that this fiber is laying nicely in the groove. See that here? There's a groove, and it's just like that. And then have to hold it with your fingers far enough so we can close the flap on it. And there's a magnet that's going to grab it. See, there's a little magnet right there, and that is going to grab the flap. Yeah. Okay, so now this thing is being held. Okay, how does it look like under a microscope? There we go. Might as well take a quick peek. That is what it looks like, and this is how it compares to the stapler that is being used to staple paper. Something that I have reference of. Okay, so now we can nicely, clearly see the coating end of that. All right. Next thing we're going to do. Next thing that we're going to do is we're going to strip the coating off of this fiber here. So what we're going to do is we're going to hold this really tight with our thumb, somewhere about here, because we're going to apply some pressure and outward tension. So we need to be able to hold that. So if we hold it strong with our 2 fingers this way, that should be fine. Now we're going to insert the fiber into the smallest groove and as close as possible to the tip of this holder, of this insert, of this die. Okay. Once the fiber lays nicely and comfortably inside the groove, we're going to close the stripper, and then we don't let go. Once we close it, we don't let go. Okay. Now, with a one sure kind of fluid motion, we're going to just pull that off here, and now we have the fiber stripped right to the cladding. Okay, so what's here? You're seeing 125 microns, which is basically 125 millionths of a meter. Okay. So that's pretty good. Let's take a look at quickly. Take a look at this thing under the microscope. That's what it looks like. You see there's a lot of dirt here now, right? We can't have that dirt. What this dirt is just a residue from the coating that when we were stripping it. See, over here you can see the tiny line that's there. That's the light reflection that goes off of the core. It's just the light hits it that way. See how the dust specks or the dirt compares to the size of the core. So we cannot afford to have any of the dirt in there. And also, I wonder if we're going to be able to see this properly or not. I'm going to try to see if we can see the end of it, to see how shattered that is. I'm just going to try to lay it down on the surface. Yeah, I can see that the tip is quite shattered. I wish we could have a little bit more magnification. But now we're going to get into the process of cleaving it. So what we're going to do, let me just prepare the focus of that for the next shot after it's cleaved, because it's going to be barely visible once the glass is nice and clean. Okay, so here we have the focus going on. All right, so that's good. All right, so next thing, we're going to clean this with isopropyl alcohol, and we have the cleaning fluid right here. We're just going to pump it a little bit, and then we have those swatches that we're going to clean this with. So what we're going to do is we're just going to make a V groove here. Okay, just like that. You cannot make a V groove against the fiber because it's just too soft. Right? So we have to prepare that first. Then we're going to basically clean the glass. See, it's barely visible right now. Right? And of course, because it's a wet this is isopropyl alcohol. Once we what happens when we clean the glass with Windex? It squeaks. It's squeaky clean. It's just like cleaning the glass with Windex almost, except it's a isopropyl alcohol. So now we got the squeaky clean. I'm going to replace that swatch face down. So the surface that touches, the idea of it is that the surface that touches the fiber touches nothing else but the fiber. If it falls on the floor and it falls on the on your desk face down, just throw it out and grab another swatch. Okay. All right, now let's see what it looks like under the microscope. All right, so here's that. Nice and clean right now, see? The dust is gone. There's still a little bit of it, which the rest of it that stays there is going to be taken care of by the pre-blast, which I'm going to explain to you during the fusion process. I'm trying to get the tip of it still, but I don't think I'll be able to. Yeah, I can barely catch it. See how shattered that is? You can barely see it. And I'm having a hard time keeping it in focus. But yeah, that edge is shattered. Okay, let's fix it up a little bit. Okay. Which camera should I use? Oh yeah. So now I'm going to grab this cleaver, and before I use it, I'm just going to make sure that there is none of the debris left from the previous from the previous cleave, all right? And I'll explain to you. You will see what I mean. Right? So remember when we opened, I'm just going to open it a little bit here for now. Okay. Again, we're going to open that. The fiber is going to lay inside here and it's going to be pushed down and held in place by these two spring-loaded levers here. All right. And we're just going to insert it that way, and it's going to go all the way through and it's going to come up on the other side, and then we're going to do the cleaving. So close it, make sure it's ready for us. All right, so we're going to slowly insert that very carefully, just making sure that this thing doesn't bulge on us. It has, of course it doesn't want to go in. We're going to have to lift those holders by pressing two buttons together. See, this one lifts that one here, and this one lifts this one here, okay? So both of them have to be pressed, but usually if you want to press them nice and equal, I'll just press them with one finger in the middle right there, okay? Now make sure that you don't have any fingers here, because you're going to get poked by the fiber, and you don't want to have that. Okay, so I'm going to release those levers, insert that very carefully, making sure that this thing goes on the other side, and we're beginning to see that. See it? There we go. I'm trying to catch the angle here. And there's a magnet here. See that little rounded thing? That's a magnet. So once this thing is far enough, the magnet is going to grab it and align it into place. There you go. See? All right. There's the magnet. Now, once this thing is inserted, grabbed by the magnet, we can release those two buttons, so the fiber is being held. Now, we're going to have two actions right now. We're going to press the red button, and then we're going to press the blue button. Okay? Once this thing is inserted, once we press the red button, we are creating tension onto the fiber. And then we're going to lower the fiber onto the blade, and in that way it's going to be cleaved, and that's all there is to it. Okay, so red, blue, this thing is cleaved. Okay, so tension and cut. All right, tension, cut. That's it. This thing is cut right now. It's cleaved. So now you can go two ways from here. You can remove the back side of it and continue with the fusion splicing, or you can remove this one here first and dispose of that properly. So I'm just going to remove that first, and first I'm going to grab it and press only the red button just to release that front part of it. Okay, so now we have that. We just have to make sure that this thing is well disposed of in the container, or sometimes there's a tape being put backwards, and then the tape is going to be disposed on into the container. It has to go into the sharps. Now we have that thing gone, and we're going to have to release that one. Okay, because this is our fiber to be fusion spliced, okay? But we cannot pull it off because it's being held by this lever here, and by operating the black button, we are lifting the holding lever, and then we can slide it out. So I'm going to put my thumb on this thing here, press the black button so this thing is released, and I'm going to slide it out. Okay. Now let's see. See, that's a cut fiber right now. Okay. Now let's see what it looks like. Align this. Here's our cut fiber, and now we can see there's this nice, beautiful straight edge. Can we see that? Oh yeah. All right. So we do have that. This is still against the staple. Now it's nice and clean, and we have a straight edge. All right, let's put that thing in to the fusion splicer. Again, I'm going to align the camera here. Here is our fusion splicer. It's an old fusion splicer, but I'm glad I'm using this one here. I wish we had something better, but this is what we have. However, the good part of that is that you're going to see the whole process. The new ones, the new fusion splicer, they're more automatic. You insert that thing, and some of them actually cleave it and splice it for you. It happens all automatically. This is automatically too, but it's half automatic. Okay, so it just comes in like that. This thing is from 1980 or no. Something from 1990 or 91. Okay? So it's a few years back, right? It's 2021 right now. So what do we see here? We have a cover. You can open this cover. I'm going to zoom in a little bit. What do we have here? Over here we have those two electrodes. Let me grab something to point with. Here's the top electrode, here's the bottom electrode, and the fibers, two pieces of fiber are going to go from the right and from the left. So one is going to go this way, and the other one is going to go this way, and they're going to be brought closer together, aligned, and fusion spliced. Over here we can see a couple of LEDs here shining from the side. This is just for us to see things better, because when you see the when we are aligning those optical fibers. So what I'm going to do is I'm going to remove that from I'll remove the fiber from the holder. See, I'm just trying to hold it to the camera here. Okay, so I'm going to hold it here. Okay, open the flap. Okay, and now I can remove this. I'm going to, all the way along, I'm going to make sure of two things. That I am not going to poke myself with that, because I can end up with a piece of fiber in my body, and we do need fiber in our bodies, but not this kind of fiber. Here we also are going to have to make sure that we don't touch any sort of surface with the tip of this optical fiber, because it's a very, very fragile piece of glass, and it takes just a slight touch to get rid of the nicely cleaved edge, and all the cleaving process that we have just done is going to just go out the window. All right, so just by touching we can shatter the glass. So the way we're going to do this, we're going to have to put that thing just like that, so it's between this holding block and the electrode from one side, and of course from the other side as well. Okay, so the way to do that, how do we do it? Very carefully. All right, now I'm just going to get rid of my little picture-in-picture here so you can see the process a little bit more clear. All right, so here is the holding flap. Okay, we're going to open that. Now what I'm going to do is I'm going to prop myself here. I'm going to put my pinky right here, so I have a steady hand. So you don't want to have my hand in the air, because I'm never going to be able to align that fragile piece of fiber there, right? So I'm going to prop myself with the pinky against that structure, and then I'm going to make sure that I have a comfortable grip on the fiber. You might want to change the angle, I think we're good with the way I'm holding right now. And I'm going to slowly lower in a way that I'm going to go down and backwards. We never want to go forward, because as soon as we go forward, there's a chance that we can bump this thing into against some surface. Okay, I'm holding it high right now. Okay, so I'm not touching anything. So I'm going to go down and backwards. Okay, on that. And before I do that, I'm going to have my finger right on this holding flap. Okay, so I can close it right away when I'm aligned. When I'm aligned and I'm going to start moving my hand towards it, I'm going to move the other hand and things are going to be misaligned again. So here I'm holding that, I'm just having my finger right on this thing here. Let's see if we can just get a little closer so I can show you the alignment process. This fiber optic has to be right between this block here and these two electrodes. That's our window of opportunity right here, between this block and these two electrodes. So I'm just going to try to reposition myself so I can be more comfortable doing this. So I don't have to look at the camera here. All right, there we go. It's nicely aligned, and I'm going to close the flap. Okay, so the fiber is between the holding block and the electrode. So that's one side. Now we're going to prepare the other side. Okay, I'm going to do a little bit quicker. Okay, first thing I'm going to do is I'm going to make sure that I don't have a residue. I know I don't, because I remember taking it out, but making a habit. So I can check it. Maybe you forgot to do it maybe this time. All right. So your cleaver is nice and clean, ready to go. Your insert is there. I'm going to grab that piece of fiber, right, and I'm going to put it in the holder. See here. Let me just get that. All right. So here I'm putting that right into the groove. And in the direction of the arrow right here. Okay, so we're going to put this right in the groove. All right, making sure that this thing is long enough so we can comfortably grab it from the other side. I would like this thing to be a little bit longer so I can comfortably grab it, so without straining. Okay. Because you don't want this thing to fly off, because then you'll be looking for it for 2 hours. All right, so now that's about as far as we want this thing to be in that holder here. And I'm going to position my thumb far enough and just make sure that this fiber is right in the groove. And once it's there, just going to close the flap. See how easy it is? So here's the flap, and the magnet is going to grab it. Flip. And it's closed. I jumped out of the groove because I moved my finger. Okay, here. There you go. It's sitting nicely in the groove right now. Okay, so then remember, we're going to hold that with our thumb very strongly here. And I'm going to grab my stripper. Yeah. Here's the fiber optic. Never ever use it on copper wire. As soon as you use this thing on copper wire, even by mistake, it's gone. Done. You gotta buy a new one. You just can't fix it. All right, so I'm going to let me just get a comfortable focus so you can see the process. There we go. Okay. And I'm going to put this fiber as close as possible to the tip of that holder or the die or the insert, and I'm going to make sure that this fiber lays in the groove first before I close it. Okay, now I'm looking at the camera, now I'm looking at it. All right, once I close it, then I just one swift motion pull it off. All right, now this thing is stripped. Then what I'm going to do is while I'm holding this thing here, I'm going to get the swatch here. I think we're running towards the end of that. Make a groove hold it, squeaky clean, okay? Can you hear it? It's just like the glass being cleaned, right? If you were cleaning windows with, with some paper. Wax on, wax off, okay. All right. So now we have this ready to be cleaved, okay? I wonder if you can see it or not. Probably not. Okay, switch the views, and just rearrange some stuff here. And we're going to put that thing into the cleaver. All right, again, there's nothing there. All right, I'm going to open the levers so we can open the channel, so we can put that thing in physically. Press 2 buttons. All right, now insert that from the rear, and making sure that this thing comes out the other end. All right, very carefully. Can we see this thing coming? Yes, there it is. You can see that. Okay. I'm trying to align it with the light so you can see. Yeah. Now, magnet is going to grab it. As soon as the magnet has grabbed it, then you can release those 2 buttons. Okay. Now the fiber is being held, and then remember, tension, cut. Right. So, tension, cut. All right. And then again, I'm going to grab this one first by releasing this half of that. So first I'm going to hold that fiber in my 2 fingers very gently, and I'm going to release it. Okay. And I'm going to dispose of that. Okay. Now I'm going to put my thumb on this holder here and release the other side. Lift the lever by pressing the button here, and now I can slide it out. From this point on, we want to make sure that this is the tip of that doesn't touch anything, because it can shatter the glass. Yeah? All right, so I'm going to just remove that from the slider, from the die, and again, I'm going to put that, but this time into the other holder from left side. Can we see it closer a little bit? Yeah, so we have the right side loaded. We're going to load the left side right now. So I'm just going to leave the flap here. And I'm going to, again, nice and backward motion, okay? Going to prop my pinky here, and then, all right. I'm going to pull a little bit out and re-angle that a little bit so I can do this comfortably. Okay, put it on. It's kind of awkward looking at the camera here. See, I'm just going to go backwards and lay it down right in the groove, and once it's there, I'm going to have my hand right onto that flap here, just so I don't have to do too much movement. Okay, here it is sitting. Is it sitting there? I can't see it on the camera because I don't have a 3D view on the camera. Okay, there it is, sitting there. Close the flap. Okay. So now we have 2 fibers aligned in front of those electrodes. You see it? Okay, we're going to make sure that they are nicely laid here. So once we close the cover, there are those kind of cutouts. So we're not going to pinch the fiber with the cover. We need to cover this because there's going to be some sparking happening there. All right. So here, make sure that everything is nice and easy. All right. This thing is closed. Okay. Now let's see what the screen. Let's take a look at the screen here. And now what you're going to see. Align that, sort of. There we go. That's a little bit better. Zoom in, focus. Okay. I'm going to press the fusion button right here. It looks like a play button. And what you're going to see the cameras. You're going to see the cameras aligning. You're going to see 2 views. one camera looking at this thing from one side, and the other camera looking at the same thing from another angle, 90-degree angle. And you're going to see those things move, and you're going to see the cladding in the core. Almost right away, you're going to see something like a pre-blast. You're going to see big light flash. So it's a pre-blast, and the purpose of that is just to get rid of the whatever is left of the dust that we didn't get off with the swatch. Okay. Now, then it's going to align a little bit more, and once it's aligned, bang, it's going to do, the spark is going to see a nice huge flash. Now this thing is old, and last time it didn't want to do it because it said it was alignment error. I know it wasn't, but it's an old piece of equipment here. All right, so let's take a look at this screen here. Press play and see. Okay, I'm going to try to talk you through it here. Okay, two cameras, you have two, and it's aligning things. You don't see it yet. System reset. All right, there we go. Press play. Now we can see that. Two of them pre-blast, see, nice and clean. Then it's going to start aligning and then blast. And come on, blast. It's all happening automatically. Here's the blast, and now you can see one continuous piece of fiber. Wow, isn't that something? 0.03 dB loss, which is acceptable. Now, when we take this out, I'm going to open the cover here. I'm going to take that out. Flap 1, flap 2. See, now we have one continuous piece of fiber. If I put that under the microscope now, let's get that microscope view. Here, let's get this in focus. If I move, you see here, those things are joined. You can't tell where one begins, where you can't even tell where the splice is. Okay. Right. Now remember when we put this protection sleeve, all right, that thing was on. Remember we put that thing on first, so I'm just going to retread that because we just have two kind of short pieces, but of course we put that thing before that. So here, now what we're going to do is we're going to align that protection sleeve so it's right in the middle of this place. Okay, and then we're going to have to, because it's like a heat shrink with a strengthening agent with a wire in it. So switch the view. Okay, and here is the oven. Okay, that's what the oven looks like. You are going to put that right here. See that that protection sleeve is right there. It's in the middle to protect the to physically protect the spliced portion. And the way it works, we just most of them work the same way. These are called ovens. Okay? And we're just going to put that in. It's going to close on itself. Close this flap here, and there is that heater button. Looks like a resistor kind of a thing. Press that, and that is going to be see, there's that little oven kind of a icon here. That's pretty cute. So this here is being heated right now, so the heat shrink does its job. All right, now when this thing is done, it's going to give us a little bit of a sign by beeping at us, and then in the meantime we can start preparing another another two fibers to be spliced. Okay, so we're just waiting for that for this heater to work. I'm just going, in this time, I'm just going to close this flap, close this cover, and I'm just going to wait. All right. Let me tell you a story. Oh, never mind. All right. So as far as the lab report, you're going to fill out the regular lab report, and I'm just going to take one picture of the test screen. Every single person in our class is going to prepare one end and insert that in. We have smaller groups, so we can afford to do that. We're just going to have to keep sanitizing the equipment. All right. All right, let's see. There we go. Here's the beep. And now, once this thing is done, we can take this out. Take it out. Now it's nicely protected, and it's going into the cooling tray. That's right behind it. Okay, so here it is. That's the single mode Fusion Splice.